is Boudmo Jiggler. It's my favorite font name. Because it's a funny 2 words to say. Boudmo Jiggler. See, it makes Vikram laugh every time I say it. All right. So, we have just finished a unit graphing real things, like flights to Toronto, hot air balloon flights, whatever. So now we are going to move into doing this theoretically, which means we are going to just use not real life situations. We're just going to be doing this with numbers. All right? So there's 3 ways to draw a linear function on a graph. I'm going to show you all 3 ways. You need to know all 3 ways, but you don't need to use all 3 ways on every question. Everybody understand? So we'll start with this first one. We already know what an x-intercept is. What is it? What do you think it is? We've already talked about it. Pardon?
The horizontal axis.
Right. An x-intercept is when a graphed line crosses the x-axis. Does everyone agree? Everyone agrees, right? Okay. What then is a y-intercept? When a graphed line crosses the y-axis. Now, you notice there's a lot of white space left in that box, yes? There's a whole bunch of white space here, yes? What does that mean? It means we're going to fill it up with something. Everybody draw a graph. Now, I need to remind you of a couple of things here. 1, every single point on this graph has how many numbers associated with it? 2. What are those 2 numbers? X and y, right? As x's go this way, they get bigger. As x's go this way, they get smaller. As y's go this way, they get bigger. As y's go this way, they get smaller. All of you already know that, right? Okay, so without actually knowing, give me a reasonable guess for what the x and y would be for that dot. 8, 7. Can I say that that is unreasonable? No. Could I also say that is 0.7 and 0.8? Yeah, it doesn't matter. Everybody cool with that? All right. So that dot right there has a value of 8 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. Whoops. You know what I mean, you silly kids. And 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. Ooh, that was better. Everyone agrees? Okay, now, if I take this line and I draw it down to here, eight, 7, right? What did I just make there and there? An x and a y intercept, right? Now, I did the colors backwards. The x-intercept is supposed to be blue. Sorry about that. What is that intercept point? Is it a point on the graph? Yes, which means it has how many numbers associated with it? 2. What are they? 4, 0. Agreed? Okay. What is this value? Damn it! It's supposed to be red. What is this value right here? 0, -3. Is everybody good? All right. Now, I'm going to draw a green line. I'm going to draw it there. What do you know about that value? What do you know about it? Do you know its x value or do you know its y value? You know its y value. Why do you know its y value, Zach? Because this is 0y. So this is some x value and 0. Agreed? What is this one? 0 and some y value. Does everybody understand that? Especially the grade 9s, you haven't seen that before. You all cool? Now, look, if it happens once in math, it always happens in math, right? That's why math makes sense. This intercept was 4, 0. An x value with 0. This intercept was 0, 3. Right? 0, negative 3. 0 with a y value. Now, this blank space up here is for that. Every x-intercept is x, comma, 0. Every y-intercept is 0, comma, y. Does everybody understand? Going once, going twice, going thrice. Okay. Let's go to this very first question here. This is written in function notation. Does function notation transfer easily to a graph? Yes, because on a graph, what does that f of x become? Is that an x value or a y value? That is a y value. So, I want the x and y intercepts for this line. Well, every x-intercept is what? X, 0, correct? Every y-intercept is 0y. What values are on this side? Are these x's or y's? X's. What are these? Y's. What is this in the equation? An x. What is this? A y. Does everybody see where we're going with this? I am going to do that one first. X equals x. So, y equals 2x plus 3. X is x. What's y? 0. So what do I put in here? What goes in here? 0 equals 2x plus 3. What's my job? Isolate x. So I'm going to bring that over there. What happens to the sign? Changes. So now negative 3 equals 2x. How do I get rid of this 2? Divide by 2, divide by 2. So x equals negative 3 halves. Is everybody good? Okay. Now we're going to do the other one. We're going to do this one. I have y equals 2x plus 3. What do I know here? X is 0. So what do I put there? 0. Y equals 2 times 0 plus 3. What's 2 times 0? What's 0 plus 3? So y equals 3. Now, do I have my coordinates? I have an x. I don't know an x. So my x-intercept is negative 3/2, 0. I have a y. I don't know a y. So my y-intercept is 0, 3. Now let's put this on the graph. Mr. Myers, I don't know how to put a fraction on a graph. Yes, you do. Who decides on how to draw this graph? You or somebody else? You do. So, if I make this 1, I lie. If I make this 1, what is this one? A half. So if I make this negative 1, I need to go to negative 3/2, which is negative 1 and 1 more. Does everybody understand? Now, that means if I have room, where do I put my 1 on the y scale? Can I put it here? I can. But should I? No. If you can keep the same scale, it's a good idea to keep the same scale. So here I am at negative 3/2, 0. What's the other dot I need? 0, 3. 1, 2, 3. Now I have 2 dots and I can connect the line. None of that is new to any of you. You all already know how to fill in tables of values and you know how to do this algebra. So should this beginning of this unit be difficult? No. Let's go on to the next one. Oh, we can't. First, domain and range. What are they going to be? What x's can I put in there? Every single x. X is a set of real numbers. What are the y's? Anything. Because no matter what number I put in for x, I can double it and add 3. Everybody good? Everybody good? Okay. Uh-oh, another one. Oh, but this one has fractions. Mr. Myers, why you got to be that way? How should I write that if I'm going to graph it? Y equals 1/2 x minus 2. What is every single x-intercept? X, 0. What is every single y-intercept? 0, y. How do I work this one? Where do those two values go if I am working with this? X goes for x, 0 goes for y. 0 equals 1/2 x minus 2. How do I solve that? I bring the 2 over, what happens? 2 equals 1/2 x. How do I get rid of divided by 2? Multiply by 2. So the 2's cancel, and now I have x by itself. What do I do to this side? Same thing. So what does x equal? 4. Should I put it on the graph yet? No, I shouldn't, because we might have the same situation as last time where we had a fraction, right? We may have to change this. So what's the y? What's going in for y? Y equals 1/2 times 0 minus 2. What's 1/2 times 0? 0 minus 2? Negative 2. So y equals negative 2. So, were there any fractions? No. So can I just use the graph as it is? Where do I put the red dot for my y-intercept? Where do I go from there? Down 2, because negatives go downwards. Where do I go from here for my blue? 4 to the right. 1, 2, 3, 4. And what do? Connect them. Because I can put every single number in there. Do you all understand? Can you all find an x and a y-intercept? See how it is exactly like what we ended the last unit with. Function notation. Everybody good? Cool in the gang. Next thing. Please highlight those words. I don't care how you highlight them, underline them, put a elementary school teacher cloud around them. I don't care what you do. But make sure you know that. Those words. Those words in words make this in math. What do you notice is in this equation that we have already been working with? X and Y. Where do I find X's and Y's? On the graph. Which graph? Every single graph in the universe is made up of X's and Y's. So we already know that X and Y come from a graph. So if I told you that this point, 3, 7, where would you put the 3 and the 7 in here? The 3 would go where? For the X, and the 7 would go for the Y. Is everybody cool? Now, that means we're left with M and B. Right? M is the rate of change. Now, if we had kilometers and hours, the rate of change is the speed, kilometers per hour, right? If I had meters and minutes, the rate of change is meters per minute. Do I have values here, or do I have X and Y? X and Y. So the rate of change, we don't know what it is. It's not necessarily a speed or something like that. So we call it the slope. And the slope we find the same way. It is the change in Y divided by the change in X. Or the change in the dV divided by the change in the IV. Yes? Yeah.
Would it matter if we put 7 into X instead of...
Yeah. You can't. 7 is a Y. Whenever you see numbers written this way, that's an X, that's a Y. Always. Now, what's left? B. A bunch of you already know what it is. B is the Y-intercept. Every time. Why is it the y-intercept? Well, look. Y equals mx plus b. Isn't the y-intercept where x is 0? So what's 0 times m? 0. And what's left over? Y equals b. Is everybody good? Everyone understands this, right? Most of you have seen it before, so it shouldn't be a problem. If you haven't, no big deal. This causes problems. Right now, this isn't on a graph, is it? But if I went like this, then what would that point be? This one right here. Give me a possible... No. Tell me what it is. You can't tell me what it is, can you? But you know that it's a negative x and a negative y, right? What would this point up here be? Positive x and positive y, correct? So, when I went from this point up to there, is that a positive or a negative change? That is positive because I went upwards, correct? Then, when I went that way, is that positive or negative? That is positive. So if the slope is the change in y's divided by the change in x's, isn't this a positive change in y divided by a positive change in x? And when you divide a positive by a positive, what do you get? A positive slope. This is a positive slope. Now, somebody always says, Mr. Myers, it's break time, and I would like to take my break. And I say, kid, you're absolutely right. Go take your break. Okay, so, as I was saying, some kid always says, well, Mr. Myers, I don't want to go that way. Okay, don't. What's that direction? Negative y. What's that direction? Negative x. So that's negative y over negative x. Two negatives makes what? A positive. Everybody cool? All right. Which means, doi, same thing over here. To get from that point to that point, that is positive. What's that? Negative. So that's a negative slope. Now, these two cause people trouble because you people mix them up. If I go up there, is that a positive y? Excellent. How far did I go sideways? I didn't at all, did I? So that's y divided by 0. What happens on your calculator when you do y, any value of y, divided by, what's the smallest number you can think of that is still positive but not 0? Point 0.0000000. We can put a ton of zeros, can't we? Now, isn't that almost 0, right? So when I do that division, I get 100 billion. As I get closer and closer to 0, this value gets bigger and bigger and bigger, doesn't it? So what's going to happen when I hit 0? It's not going to exist because it's going to be infinite. So this is what we call an undefined or infinite slope. This is how I remember it. If I was skiing, you guys are young, none of you ski. If I was snowboarding, because you all snowboard because you think it's better. If you were snowboarding and you went off of this, would you be snowboarding down this hill? No, you would be falling because this is not a slope. This is a cliff. Does everybody understand? Now, you're smart kids. Oops. This down here is the opposite, isn't it? If this is an infinite slope, what is the opposite of infinity? If infinity is everything, what is the opposite of everything? Nothing, which is, in math, what number? 0. This is a 0 slope. Because, of course, I didn't go up and down at all, so I have 0 divided by an x. And that's allowed. You can't divide by 0, but you can divide 0. Here's how I know. How many pizzas am I holding in my hand? None. All of you can have the same amount of pizza. How much pizza are you getting? None, because there's no pizza to divide. Everybody understand? The way I like to remember this is if I were snowboarding and I was on this, would I be moving? No, I'd be doing that stupid thing snowboarders have to do where they hop like a bunny and look like idiots. Us skiers, we just glide everywhere. I snowboard too. Don't worry about it. Do you snowboard? What? You don't do either? Oh, yeah, I forgot. None of you like being cold. It's cold on mountains. All right. So, why do I have this much blank space down here? Same reason I always do. Yo. Screen went blue again, son of a... This is exactly when it happened yesterday. Son of a bee.